All right, now one thing is I typically, when I present, I'm a roamer, and I've been told I have to stand right here. All right, so this is going to be very difficult for me to do. But one other thing, yes, my name is Snowden, and to the folks in cybersecurity, to the best of our knowledge, we are not related to Edward. So you don't have to worry about anything that goes on, but to the best of our knowledge. But again, the background, the roles have changed a little bit since that bio was written, but still in the space of reliability and actually trying to champion the use of our new tools. And that's really what I want to talk about is the use of these tools to discover, correct, and then analyze the data that we have within the maintenance space. Because for me, the goal is to improve the reliability. And that's what we're going to talk about. I'm going to focus on this. You'll see that my slides are rather sparse, and that's by design. But we're going to talk about data quality and work process, because as we go through this, it's important to understand where we are in this journey. As you have heard from Peter this morning and from other Dow reps, Dow has been on a journey to go to a single ERP. And then we have collapsed 7 different computerized maintenance management systems into one, EAM, that then resides within SAP. But way back when we went down this path, we had these 7 systems that really didn't talk to one another. They were basically regionally based, and we could not, as reliability practitioners, get a total look at the company very easily. So that if I wanted to look at the performance of centrifugal pumps in North America and compare it against Europe, that was very difficult to do in the old systems. It took a lot of effort. And what we want to talk about is some of that data quality. As we went into this singular system, then we also realized that we had to change the culture around how we gather data. And the fact that we're going to go to a single code set, a single taxonomy, a single set of describing our equipment and using that to then drive improvement. Now, I don't know if you've ever been involved with any of that, but there's a lot of homegrown, I want it my way, and there was a lot of resistance to going to this. So early on in this project, we had to go through a harmonization. What we tried to do was clean up the data sets before we ever even moved them into our new ERP. All right, so there was a lot of work at trying to get folks to go and get those data. If we had a centrifugal pump aligned to, let's say, an electrical motor category, we got it all cleaned up, and then we brought it, after we'd gone through that data cleansing process, a rather extensive data cleansing process, we then brought it into our new ERP, and then that's where then I get a chance to look at the data. All right, so we're going to go through this, and I just want to build, because at the end of the day, this is it, all right, on an absolute mission within my little sphere space to improve the reliability of our equipment. All right, that's my little corner of the world. When you look at everything else that's going on in Dow, that's what we've got. So we're going to talk a little bit around that, talking about the data quality. So we have this single enterprise-wide business management system, and if this works down, now I just want to share with you that we have 2 other tools that we use to allow us to do this analysis. I can stay in that enterprise-wide business management tools that we have. It's very difficult for reliability practitioners to work in that world. So we do use the Meridian APM. We sync that up every night with our ERP, and we bring anything that changes from a standpoint of costs and equipment history into that system so that we can easily get into it and look at the data that's in there. And then we also have, working with Meridian also with Asset Answers, which is an incredibly powerful tool for comparisons. Comparisons between sites in Dow and with other peer companies that also belong to the Asset Answer group. So we do a lot of comparison. So I'm not going to spend a lot of time in those software packages. I want to talk about the learnings that we get by using those as my first filters and the tools at which I do the work that we do, okay? All right, so the data quality, what we found, it was really interesting. We did a lot of work to get the data right before it went into the ERP, and a lot of folks worked very hard to make that happen, but there are always errors made. And as I started analyzing data and working with people to drive the use of the tools that we have, we started to identify places where we were either missing data, we found that things weren't what we thought they were, and that in often cases we're going to find gaps in how we apply our work practices for gathering that maintenance information, the activity on the equipment. And it's very eye-opening to go through and do this kind of work and show these folks. And I just want to give you a couple examples of what we did. Again, looking at the data, we tried real hard to have the quality data on the front end, but sometimes it didn't get there. But just to share a few things on that. I'm not going to spend a lot of time here. This is one of the first places I use to drill down. Asset Answers provides the data to keep moving in. They give us some metrics so that we can follow, so we can look at how we're doing things. But I really want to key in on something. This is really is a summary of plant performance at the average corrective work cost, all right, by sites in a region of the world. Now, when I look at that, I got to say I got a problem someplace, right? That gold part of the pie there is definitely out of whack with the rest of the with the rest of the sites that we're comparing. And these are all, in essence, now this is dummy data. This is representative of what we found. Now, so we started asking the question: what could that represent in our data sets? What might that represent if we're looking at average cost? And let's say that we're not in North America. We're in a different region of the world that has. Anybody want to hazard a guess as to what happens when we fixed one set of data? Anybody want to hazard as to what that might be? Again, looking at costs. What's that? Actually, it was currency exchange rates. Everything is supposed to be expressed in USD in our system. We bring it all back to US dollars. And we had one country that was coming in, and when I looked at the data original time, I was saying, that's interesting. The data is consistently 2,063 times more than the other sites. And that just happens to be the exchange rate of the Colombian peso against the US dollar. It was right in the 2000. But what we had an error in the data set. The point is that once we started looking at it, we were using these tools, we found that we had error in the data set. We were able to go back out and correct it. That would drive that engineer sitting there trying to explain his gold in Colombia, what's going on there. It would drive him crazy. But with a more macro view and being able to see things across the company, we were able to identify these things. And it truly wasn't a currency exchange rate. We got that fixed. And as I say, once I fix that, I get to go work on something else, because that's the whole drive, to be reliable, but getting the data right. We've got to get the data right on this. And that, again, let's go a little bit further here. Data cleansing, getting correct data, purge corrupting. Again, I don't want to spend a whole lot of time on the slides, but if the data's not right, I can't be a reliability practitioner, right? If the data's not right, I can't do what I do. And that's what drives reliability analytics and equipment history data. Because if you're not getting it, then we don't have that data to work with. And we still have the gaps that we had before. Only before, we blamed it on these antiquated systems. Now we've removed that excuse. Now we can see it using these tools in the new ERP. We can see this data so much easier, readily. And we can talk a little bit about it. Now let's go with taxonomy, because I want to share with you another point. This goes back to our data cleansing. Everybody knows taxonomy, right? Just a structure. So every piece of equipment in Dow has been characterized into one into a category. And this is another thing that we cleaned up based on best practices in the industry. Before we started down this path, we had it's been reported to be over 5,000 different equipment types. All right, 5,000. Anybody want to hazard a guess as to how many we have now? Going to, again, a global data set that applies everywhere. I'll jump to the punchline. What we have are 6 categories, 76 groups, and 471 object types. So right now we have right at 2 million pieces of equipment in the ERP database. Each one of those has been assigned one of those 471 object types. Now, do you think it was perfect? No, it wasn't perfect. We worked real hard. Again, this is just so we're going to drill down. We've got some things here that drive reliability, if you're familiar with it. These are the big four. If you go to Society of Maintenance Reliability Professionals, everything is in fixed assets, rotating electrical instrument. As someone in a previous session said, Dowizes. We added two more. We broke civil out of fixed assets, so we have civil, fixed assets, rotating electrical instrument, and then we put all our safety devices in a sixth category so that we could find them. But then on the catalog profile, and this is where it gets real important for the reliability engineer, there is a specific profile of a failure code, a material code, a damage code, a cause code, and what we did to it to return it to its original surface, okay? Those codes match up to each of those 471 groups. And that's how I, as a reliability engineer, get to do my job, because then, if you're familiar with the science of it, especially if you're doing a Weibull distribution, it only works on a object type and a single failure mode, right? You can't mix them. I can do that in reliability growth, but not in a Weibull if I'm trying to figure out an efficient way to do PMs, whether it's you do preventative or predictive, all that comes into play. But I can't do it if I don't have the data. Well, now that we've got one global set, we can go in, but we find lots of issues there. And this is just an analytics. This shows all those categories. It's one way of looking at it. But we use these tools to drive some things. Now, I don't know about you all, or you can see some of those things, but like the maintainable item description, and I could show you the metrics within Dow. This is dummy data. This is not Dow data, but we're not too far off of it. There's the famous use of other. Now, I don't know about you guys, but I can't fix other, all right? I cannot fix other. And I cannot fix unknown, right? And unfortunately, we do put those in there. I wish we didn't, but we do. And what we learn from this is that when I show this to the other reliability practitioners around the world, we start saying, where's this data coming from? Where is it coming from, and how are we getting this data? And again, way back 6 years ago in our original design, we put together a very robust way to capture this data, and we depend on the craftspeople in the field to specify this. All right, we depend on them to do that, but it goes back to that catalog profile. You have to have the equipment in the right category. This is another tool just to show we use the tools we've got. You can see very early in this, we had a lot of equipment that was it was not specified. It didn't have an equipment category. And we had to go through the process of cleaning that up. We have to go through the process of cleaning up. I think if I were to run the reports now, I really wouldn't find any. Again, this is dummy data based on information provided by Meridian, but we saw similar things. And we had to fix it and go out and fix it and get all the assets in the correct category. And that's just a category. That's not the group level or the object level. That's just getting them in the top six. Right? But we use this, but we can keep drilling down, and that's what we've done. Now, the interesting thing is we can drill down through this. Doing a top 10 report, found a $185,000 repair to a pressure transmitter. All right, $185,000 sounds pretty high for a pressure transmitter. Well, when you do the little digging on it, you find out that what it actually was is somebody had put railroad tracks against the instrument pressure transmitter. All right, the system's not clean. That was fixed within 4 hours. But the point is, in using these tools, we were able to identify where we had problems with our data, and we cleaned it up so that, again, reliability practitioners can get very, very good at their work to drive those reliability improvements. Fascinating to look at the data. You know, as you heard, Six Sigma, data geek, I love it. You know, I'm sorry, drives my sons crazy, but again, we fix this, I go work on something else. Right? We work through that, the whole process. There's other things in here. Well, this is where I sort of jumped the gun. This is just one. This is sort of our data it's looking at, but when 35% or 36% is other, I can't fix other. You know, I cannot understand what that is. So we work with this. We show people how to look at their equipment history data quality so that they can go back and drive improvement and go through that. I'm not going to spend a lot of time with the graphs. The point I'm making is that the new technologies that are available in the ERPs, and when you match it up with the other, allows you to look at data a lot cleaner, a lot quicker, and a lot more efficiently, and to drive for those improvements. And what I really would like to do is get down to, why are we doing it? At the end of the day, I got to make money for the company, which means my assets are running. I got to do that. So we go through and we work those. Let's go back. Okay, here's talking about data quality. These are some questions that I love to throw out because it generates discussion even within Dow on these, because we have some really good work processes in our maintenance world, but again, we implement them differently or apply them differently around the world. But and it would be interesting to have this discussion, maybe tonight at dinner or whatever, or tomorrow. Do the craftspeople understand what you're asking them to do? Again, our hallmark is they select what they fixed, what the damage was, what the cause was, and what the maintenance activity. Reliability practitioners can also put that in there. Their role will do that, but we ask them, do they understand what they're doing? And as an RE, back in the days when as they say, tell me I had a real job, I did explain that to some shop guys, and they took me up, and they literally said, okay, big boy, we're going to do that for the next 3 months, and you got to show us what you're doing with it, all right? And that's what I share with the reliability engineers, practitioners, is show the craftspeople how you're using the data to drive improvement, and they always respond. It's really been great to see that, all right? Do you make your work process easy for capturing? Way back in our design, when we were looking at the new ERPs, we built that in to share data. Now, when we went through the data gap, we also found something. We give you the flexibility to turn some things off. We have a thing called shop papers, which gives you the description, the task list, parts numbers, and then it gives you the catalog profile for that piece of equipment. Unfortunately, that catalog profile is really long, and folks were turning off the print the catalog profile. So craftspeople were never getting it. So when I show them their data and they've got empty cells, and we started asking, well, why don't you have the data? And they asked me, why do I not have the data? I said, well, how are you collecting it? And they immediately, they were able to go back and turn the shop papers on like that, and they started correcting data, and now they're leading the pack. They saw the value in that. And our new tools, our new ERP lets us do that, all right? We also have, to speak to really the sort of the second and third is when you find bad data, we have very rigorous data governance. Not everybody can change things. It has to go through a process. And we put it to a very specific role that then goes in and changes the data. It's not difficult. You just have to submit a form, and folks will update that. So I can get those railroad tracks off the instrument and get it into another one. I also just found at one site we have a dock for seagoing vessels. The dock is on an elevator taxonomy class. And that was fun to find. And they guys started, no. Yeah, it's there. Let me show you. So, but we have a process for doing that. And that's what we put design as a best practice for that, putting that in place. Do you include a periodic audit and data validation step? Early on in the design, we talk about I was involved with culture change, because there's a hallmark, or there's a white paper out there that's considered the seminal paper on that software installations, over 85%, if I remember the right number, although they work technically well, they fail to bring the value that they were meant to bring because we didn't change the culture to use the new tool. And way back when, early on in this process, that's the group I was in the culture change, working with the craftspeople and the operators, basically at the field level, with them to understand what we were doing, why we were doing it, and how to get them to use these new tools effectively. And still on that mission to do that, all right? And then quality metrics. How often are you using these simple queries we've built to go look at your data, and then are you tracking performance improvement against that? And some of the sites that are very serious about this have started doing that now that we've got all of the company on that. All right? I'm going to talk about one last thing before I finish here, and this was back when I was doing the real job of reliability engineer in the unit. We have a work process that requires us to look at our bad actors once a year. And it's the ugliest event for the RE that there is, because we always had to go get that data, and it was hard to get. But we basically look at what's the cost, the number of events, and then the impact on production, right? Pretty classic stuff. And we combine it together, and we look at it, and we try to drive those things. When I was an RE working in one plant, we made synthetic rubber, had big compressors and packaging equipment and things like that. In our old systems, I think I have a slide on that just to finish up here. It would take me at least 3 days of an iterative process to submit to have a report run, because they only ran the reports out of the the ERP in the evening when computer time, processing time was low. They'd give it to me, and I go, oh man, we missed it. And then we'd have to go back and get it, and then we'd spend times doing analysis. I'd have to kick it into spreadsheets and create pivot tables and things like that. That was one plant. It basically was the better part of a week of literally hell for the RE at that time, trying to get that data and look at it. Using the new tools that we have, I was able to do an entire hub, what we call, which is a collection of plants, regionally collected. I was entitled to do an entire hub, which had, I think, 12 plants in it. On the left side, that was one plant. On that side, it was 12 plants in 5 sites. I could do it in less than 90 seconds. I could bring up all of my bad actors ranked up, and then literally just a couple hours of analysis, I would understand where I am. That's an incredibly powerful improvement in our efficiency around that process of being able to get data. And we exploit these tools that we have added onto our ERP so that we can do that analysis, all right? And that's just about it. This looks at, we can go down. I don't want to take up any more time, just showing we have ways of filtering. This thing's called a bad actor identification. I can go into, within Dow, I can go to sites, I can go to regions, I can slice and dice the data however I want. And it's very careful, it's very well built this way. I can do that in our ERP, but it's very difficult. It's time consuming. Here it comes out very quickly. Again, it gives us nice summary tables of these things at each of the levels, things that we need. And again, this pops up very quickly because we're synced in very, very closely. All right? It even pops up so I can go take my work history. I can look at my bad actors, then I can go back to my ERP or into our other data analysis tool and go right there and find the data and look at it very quickly. So that's the end review. That's what I think this is. Should be it. Yeah, 90 seconds to do what that would have been quite a few man weeks to do that work in our old system. But was able to do the entire thing in about 90 seconds. Because at the end of the day, as I tell people, we've taken away struggling with getting data, and now you get to go play engineer. You get to be an engineer and apply these, all right? So what we've got is we've got a data-rich environment. How do we get the data? We've got to make sure it's good. We spend some time doing that, cleaning, screening, all right? And I'll leave you with this. You've probably seen this, right? All forecasts are wrong. They just get better with more data. I would say that really all the comparisons we do within our company are wrong. They just get much better with a lot of quality data is what I drive for, quality data. All right, with that, thank you.